Hi everyone. Today I am going to start a complete Verilog playlist in English on YouTube. Here I will cover all the Verilog concept as well as all the basic digital circuit designing. So in this course you will get all these things. So to start this course you should know the digital electronics because in this Verilog course we are going to design almost all the basic digital circuit using Verilog. So this is the prerequisite. Now the second thing is where you will get the notes of this session. So you will get the notes of this session on my Telegram channel, that is VLSI Pro. You have to join this Telegram channel. To join, you just open video description box, and there you will find a link. Just go to that link and join this Telegram channel. Okay, so let's understand the flow of this session. So the flow of this session will be quite different, not whatever you are seeing on YouTube. It will be different from them. So how it will be different from them is the learning flow will be, first we will learn all the basics concept of Verilog with some basic example. Concept means all the Verilog language constructs we will learn, all the Verilog keywords we will learn, and apart from that we will learn the concept. Later on what we will do is, after learning this all concept things, then we will see how to design the digital circuits. What are the digital circuits we have? We have various gates. So we will design these various gates at various abstraction level. Then we will design all the combinational circuit. Apart from that, later on we will design all the sequential circuit including FSM. Okay, so this will be the our learning flow. So let's start with the very first question, that is, why do we need see, the good thing is, when you are going to learn any things, any subject, just start with a problem. Okay, so we will start with the problem. The question is, what is the question is, suppose I want to design a digital circuit like an AND gate counter or any digital circuit you are going to design. So how do I tell a computer that I want to design the hardware, I want to design this hardware? See, the thing is, we can manually design, right? We can manually on pen paper we can design. But what happened nowadays, the chip that you are seeing, that has more than billions of transistor, billions of transistor. So manually designing these many transistor, it is not a practical way, right? So here this is a problem. So to solve this problem, computer is there. So we will use a computer to design that much of complex circuit. Okay, so what will happen here is, we will take the help of one language. Using that language, we will tell to the computer that I am going to do this. So what will happen here? If you use a programming language like C, so in that case what you will do? You will write like this: A is equals to 10, B is equals to 10, and C is equals to A plus B. So this tell to the computer, means this computer, this is our computer, to perform the operation. This is the operation which you are telling your computer to perform. But when designing hardware, we need to describe the things like this. When you are designing the hardware, you need to describe the things like this. See, A I am giving, then I am giving B. This is the input A and B, and then you perform the AND operation, and you should give me one output. This is how AND gate look like, right? So we need a way to describe our hardware design behavior. You got it, right? We need a complete a way to describe our hardware design behavior using a language, or using something. That something is nothing but your Verilog. So using Verilog language, what will you do? You will describe the behavior of the hardware. So what hardware exists, how hardware is connected, then how signal flow, how the hardware behaves with the time, all those things. So that is where Verilog comes in. So all those things you have to tell. So that's why here we have Verilog. Now the thing is, how C language or any software language, whether it is Java or any software language, Java, C, C++, any software language, how it is different from Verilog language. So here I mentioned, see, C is a software programming language. Yeah, that is correct, right? It does not have concept of time. here we will implement the time, because any hardware circuit will not give you the output immediately, it will take some time. So when you are going to define that circuit, when you are going to define the behavior of that circuit, that time you need time. So you need to have time in that language, then only you will be able to model that hardware using that language. So in C we don't have concept of time, so we cannot use C to model the hardware. Now it cannot run multiple process concurrently, it cannot run multiple process concurrently. And then in a Verilog is hardware description language. Okay, it implement concept of time, it has a concept of time, and it can run multiple process concurrently using fork join. Multiple process means, see, when you are in a real time, your processor is not performing a single task, it can perform, I mean it has multiple cores, means it can perform multiple tasks at a time. Okay, now we will see what is Verilog. So Verilog is a hardware description language. This is the very important, right? Hardware description language, or HDL. HDL. Okay. This is the short form of hardware description language. HDL, used to describe and model the digital hardware. Digital hardware means digital circuit. So we are using this language to model or describe the behavior of digital circuit. Hardware things like AND gate, multiplexer, flip flop, counter, memory, CPU, SoC. These things. Okay. Description means what? See here, hardware and then description. Description means we are not physically building the circuit, describing the behavior of that circuit. We are not building physically of that circuit. Instead, we describe what the hardware should look like and how it should behave. Okay. So if you ask me, are we doing this physical implementation of AND gate? No, we are not doing. But we are modeling in such a way so that this will behave exactly like a hardware. So this is how we are modeling. So this is module. I will tell you what is module for you now. It is totally new things. In the separate session we have, where we will discuss what is this module. Okay, so just see here, module and module. Then here you have input and output. Now A and B is the input of the AND gate, and then Y is the output of the AND gate. Okay, and then we are assigning, we are using some keyword, that is assign. I will tell you each and everything, what is the meaning of assign, what is meaning of module, what is input, why it is input only, why not it is output, everything I will tell you. This is just an example how we are modeling. So this is the code in Verilog, and this is actual hardware. Okay, so this is a description of this gate. So whatever you are seeing, this one, this is a description of this AND gate. Now you may have a question like, why does Verilog exist? Why does Verilog even exist? So I told you, imagine designing a processor. You are going to design a processor that contains how many 10 millions of gates. So would you draw every gate manually? Is it possible to draw every gate manually? No, right? Obviously not. So you need a way to describe this hardware using text. You got it right. So that is why we need Verilog language. To solve this problem only, we came up with the Verilog language. For example, you are doing like this: assign y is equals to a and b. This is the AND operator. This is the assignment operator. The designer can describe the required logic using Verilog. So this is the designer can describe this logic using Verilog. Then the tool can take this description and perform different tasks. Okay. Now the tool will do like this. It will take the Verilog code. The tool is like a simulator only. This is a simulator. So you will simulate this, and what you will do is, then you will check that this design is behaving correctly or not. First you wrote the Verilog code, you give to the tool, then you check that this is AND gate design or not. If yes, then you will use another tool to synthesize this. Synthesis means you are converting your code, like module and module, you seen this, right? You are converting this into this format. So that is nothing but a synthesis. That is a process, that is called as synthesis. After synthesis, this is a process. After synthesis, you will get gate level netlist. Hardware, you will get actual gate what you are going to implement. Okay. So Verilog act like a bridge between designer hardware idea to and electronic design tool. Okay. What problem does the Verilog solve? You got it right. What is the problem? Okay. You can read. You can go through this. You can read whatever I mentioned. You can read, or else I can read also. There are several problems that Verilog solve. What is the problem first? Complex hardware is difficult to describe manually. You got it right. If 10 millions of gate is there, then how will you describe using just drawing the circuits? It's not possible, right? And the second problem is we need to verify hardware before manufacturing. So here we need to verify also that whatever the design we wrote, that is working correctly or not. So to do that also we need a way. So using Verilog, we will design also and we can verify also. Verifying means what? Suppose you design AND gate. Now your AND gate should behave how it is. Suppose you design this is your AND gate. Now it should behave when both input is 1, then only output should become 1. Otherwise any input is 0, then output should become 0. So this thing is we need to verify before manufacturing. Once you manufacture, then you can't do anything. So before manufacturing, you should verify this our design is behaving as expected or not. Okay. So to do that also we need one language that we will that is also done by Verilog. So you will use Verilog to do this part also. Okay. So we can verify the behavior before hardware is manufacturing. Now we need to convert our design into the actual hardware. Okay, so Verilog can be processed by the synthesis tool. So this language is processed by the this language code. Whatever the code you wrote in Verilog, this will be synthesized using synthesis tool, and you will get the actual hardware. Okay, so this part you can go through once. Whatever I explained, this part explaining the same thing. In the later session, I will tell you other things. This is just an introduction part. So here I told you the basics. Why do we need Verilog? What we are doing using Verilog? What will we do in our uh, digital circuit implementation period? What we will do using this Verilog? Okay, so I told you all those things. Just stay tuned for the next video. Bye guys.